Hi, so today I'm going to introduce something called the homopolar motor. And what makes this motor unique is that it doesn't need the current direction to be alternated. Whereas in a commutator brush motor, the current direction actually needs to be rotated. So basically what it involves is a battery source, magnet, and some conducting wires. And basically I'll explain the physics behind it. Current runs from the positive terminal to the negative terminal of the battery. Positive here and a negative here. So it runs from the top to the bottom like this. And so it'll run from in this direction too. So you have like current vectors going down like this. And what happens is the current interacts with the magnetic field lines, which come out from the top of this, from the north pole to the south pole in a magnet. So these are going like this, as the diagram shows. So the current interacts with the magnetic field lines, and a rule that dictates it is the right-hand rule. And this equation here shows the vectors form of it. So the vector I cross vector B, the right-hand rule will show this, will give the force vector, direction it points in. So if we put our fingers in the direction of the current vector, which points down, in this case right here on this side of the motor, and we curl our fingers in the direction of the magnetic field lines in this direction, then the force vector comes out like this. Our thumb gives the direction of the force vector. So that shows in this diagram that it's pointing out with a dot coming out of the page to signify that. On this side, it's the current's going down, and we curl our fingers in the direction of the magnetic field lines in this direction. So the force is going inwards, and this creates a torque in the motor, in the armature, and it turns it. And it turns it in the clockwise direction. So basically, I will show you. Oh, and most of the force that turns it, there's some up here, but most of it's on the sides, because that's where most of the force is, and a lot of magnetic field lines are going like this, and there's some up here, and they go like that, and most of the interaction is along the sides of the motor. So I'll show you what that looks like. And the way I have it set up right now is it will rotate in the clockwise direction, because the north pole and the south pole are set up like this diagram. And that's how it runs. It's rotating in the clockwise direction right now. And so I would want to show that if I change the direction of the current, so in this, and I keep the magnetic field lines in the same direction, and I make the current go upwards this way by reversing the side, top, and the bottom of the battery, it actually rotates in the opposite direction. So because of using the right hand rule, and the vectors change direction. So if my eye's up this way and my magnetic field lines are going this way, and I curl my fingers towards that, it goes into the page on this side, and then out of the page on this side. So it will rotate in the counterclockwise direction. So I'll actually show you something else, and that is basically if I keep the current going in the same direction as the first case, and I swap the field lines, I swap the poles of the magnet, and I get magnetic field lines going upwards like this. That also changes the vector. So you'll have I going down like this, and you cross your fingers towards B, which are going in this direction, and you get a force going into the page. And basically that will also give a torque that rotates the motor in the counterclockwise direction. And and after getting it set up, this is what it looks like. It's rotating in the counterclockwise direction, as you can see, and this is with the south pole on the top. Thank you for watching my video.